Hello, this question is the longest continuous subarray with absolute difference less than or equal to the limit. So basically we are given an array and a limit, so you have to return the size of the longest non-empty subarray such that the absolute difference in the subarray which is less than or equal to the limit. So this question is pretty tough, so let me summarize again. So when you have this array, right, the subarray could be this, the subarray could be this, right? So you have plenty of subarray, so you have to be a continuous subarray, right? So this is also the subarray, this is also the subarray, this is also the subarray, right? So when you have a subarray, right, and then you have to find out the maximum value in the subarray and the minimum value in the subarray, and then when you subtract, then the value between the max minus d, max minus min, right? If this is what less than or equal to the limit, right? Less than or equal to the limit, and then you increment by 1 because this is the size, right? So I would say, okay, this is going to be it's not going to be a continuous subarray. I mean, it's not going to be the longest continuous subarray with the absolute difference less than or equal to the limit. So I'm going to just get rid of this. So let me try about this one. Yes, this is definitely is, right? 4 minus 2, and my limit is actually 4, right? So which is less than equal to the 4, right? So increment by 1, and when you increment by 1, since you already know the index, so this is j, this is I, something like this. This is the sliding window, and then j minus I plus 1, right? Because the index started from 0, right? And so I'm just go straight about my solution. So what you need to do is you need an ArrayDeque. So ArrayDeque is pretty easy because you can actually pick first, and then pick last, and then pull first, and then pull last. So when I traverse the array, right, I'm going to start it from 0 definitely, right? Then for every single time I need to offer last. When you say offer last, which means you are putting a number at the end of the ArrayDeque. So ArrayDeque has a lot of functions, so just make sure you know. And then when I traverse the when I traverse the nums, right, and I also traverse my ArrayDeque. So I have 2 ArrayDeque. I'm going to change another color. So this is going to be max d, and also another one which is going to be min d. So these 2 ArrayDeque has a really important tool. So basically I'm going to put my maximum value. If there's a maximum value, I'm going to keep pushing into my max d, and then if there's a minimum value, I'm going to push into my min d. So for every single traversal, I'm going to check, does my max d minus the min d which is greater than limit. If this is it, right, then I need to move my pointer right by 1, left pointer right by 1, because the sliding window, because you no longer need that value for the sliding window. So just basically this is 8, right, and then my right pointer is this. So I already know like this is it's not going to work because 8 minus 2 is 6. 6 is greater than limit, right? So I need to move my pointer by 1 no matter what, because this is not going to satisfy my solution, and I'm going to traverse my right pointer, and then so on, right? But the problem is what? For every single value, I need to append to max d and min d, and I also need to check, does my current value at my left pointer, does my current left pointer value is actually equal to the max d or min d? If this is true, I'm going to just pull out, because because one of the reason is you are out of the is going to be out of limit, right? So you need to pull, and then you increment your pointer, and for every single traversal you also need to update your maximum result, which is the size of the result, right? The size of the result, right? So this is the solution. So let me start coding. So I have a ArrayDeque. I'm going to put an integer in my ArrayDeque. So I'm going to say max d equal to new ArrayDeque and min d new ArrayDeque. And I also need what my left pointer. I'm going to say I equal to 0 and also my return value result, which is going to be the size of the longest non-empty subarray, right? So I need to traverse my pointer, sorry, my value array. So I'm assigning my right pointer as a j and left pointer as a I, right? So once again, you need to what? Put every single value, offer last numset j into the ArrayDeque, right? And then so we definitely need to put the value into the ArrayDeque, but we also need to check, does my current value, and when you compare, right, and if this is the largest one in the maxd or the minimal one in the maxd, if this is true, then you will just have to poll. So we offer last, we put the value at the end of the maxd and minD, but if the current value, if the last input value, which is less than or greater than the minD or maxd, you need to poll. So I need to make sure I have something in my ArrayDeque, right? And also my current value, which is greater than maxd dot p last, right? So my current value is greater than the last value I put into the maxd ArrayDeque, right? So I need to poll. So maxd dot poll last. So this is going to be exactly as similar. Min d is not empty, and array numset which is less than min d peak last. Min d poll last, right? So if there is a current value, if the current value which is greater than the value already inserted into the maxd, then you need to poll, because this is now the largest, this is now the maximum value in the subarray, and this is exactly the same thing. If the value in the minD, if there is a value smaller than the minD, which is the last one, you need to poll. Like this is the smallest, right? So, and then for every single time, you just have to update your result, and then it's going to be j minus I plus 1, right? But I haven't moved my I pointer. This is because you need a if statement. So if maxd dot peak first minus min d dot peak first, which is greater than limit. So so the question is what? Less than or equal to, right? So I need to make sure if this is greater, I need to what? Get rid of the current value in the min d and max d, and I increment my left pointer. So this is the condition, right? So you definitely need to think the reverse way. So if the maxd dot peak first is equal to the numset I, right? So I'm actually checking the first value in the maxd and minD, and if the first value in the maxd is equal to the numset I, which is starting from 0, which is what you need to poll, right? This is max. And also if the minD peak first is also equal to the numset I keep typing wrong, and then just minD dot poll first. And then so these two condition is definitely something that when you want to get rid of the value you don't want. So just for example, it's 8, right? So you just have to increment your I because when you enter this condition, which means there is a value you don't want, it doesn't matter it's maxD or minD, so it's a left pointer value, right? So this is going to be a solution, so let me run it. So hopefully I don't have a mistake. Alright, so this question is pretty hard for sure. So let's talk about time and space. So this is a space. So maxD and minD, the worst case scenario you can have is all of n, right? Because you can put every single value into the ArrayDeque. And this is going to be a time. This is all of n as well, because you have to traverse every single one of them in the nums array. So space all of n, time all of n. So I know it's a little bit hard, so I'm gonna just set a breakpoint. So probably right over here, right over here, and right over here, and right over here. So if you have time, so you just keep watching, and then I'm just quickly just keep next. So just pause anytime if you have any question. So just keep watching the value when you go on the next traversal, right? Alright, so this is a solution. So if you have any question, leave a comment below, subscribe if you want it, and I'll see you next time. Bye.